What's up, guys? It's Talha here again today, and today we are going to continue from where we left off yesterday. So, yesterday I solved some questions from differentiation, and today we are going to do the same thing, but we are going to left off. So where we left off, where we left off yesterday was the more easy definition of differentiation, differentiation, and then I'm going to solve some questions from that as well. So this is going to be the alternative formula for your derivatives. So the one formula for differentiation or finding the derivative is that what you do is you take the limit of h, and when h approaches 0 you take f of x plus h minus f of x divided by h. So this is the formal, or you can say the normal definition of a derivative, the formula you can use to find the derivative of functions. But the alternative formula for derivatives, and you can say the more easy one is, for example, if I say that z equals h plus x. So for example, if I say that the distance, so for example on the graph I say that this is x and this is h, and I say that this distance is z. So this is z equals x plus h. So here h will be equal to x minus z. So h equals to x minus z, and the only way h is going to approach 0 is when z is going to approach x. So if z is going to approach x, it will be h equals x minus x, and it will be 0. So using this result, we can derive a more advanced, or you can say the more easy formula for the derivative of a function. So what we conclude from this is, if we say that limit of z approaches x, so when z approaches x, h approaches 0. So when z approaches x, f of z minus f of x divided by z minus x. So this is the alternative formula for your for the derivative of the functions. So using this formula using this formula, we are going to solve some questions here. So it's given that use this formula to find the derivative of the functions in exercises 23 to 26. So what we are going to do is take the first question, that is the 23rd one, that says if f of x equals 1 plus x plus 2, x plus 1 by x plus 2, so find the derivative using this alternative formula. So what we are going to do is solve this question, and we are going to utilize this formula. So here f of z means that you have to replace so in this function you have to replace every x term with z. So here we have x, so we can write this formula, f of z minus f of x divided by z minus x, and what we can do instead is replace this x by z for f of z. So it will be 1 by z plus 2 minus 1 by x plus 2 divided by z minus x. Now we are going to solve this the factors. We are going to take the LCM. So the LCM will be z plus 2 into x plus 2, and when we are going to multiply each term by the LCM, we are going to get x plus 2 minus, and when we're going to multiply this, we're going to get z plus 2 minus z plus 2, and divide by z minus x, and when you shift these two terms down, you're going to get x plus 2 minus z plus 2 divided by z minus x, divided by z minus x, uh, z plus 2, and x plus 2, x plus 2. So alright, so this is x plus 2, z plus 2. Okay, so now what you are going to do is, so you got this, okay, so now we are so what we want is, we want to cancel out this z minus x terms, because when you will multiply this, or what was the question, x plus 2. Alright, so let's see what we did wrong. 1 divided by z plus 2 minus alright, so minus x plus 2 minus z plus 2. So yes, alright, so let's, okay, so this is the continuation. So let's open the bracket. So this will be x plus 2 minus z, and minus into plus, minus 2 divided by z minus x, z plus 2, and x plus 2. Alright, so this 2 is going to cancel out. We'll get x minus z, and z minus x, z plus 2, x plus 2. Now so we want to cancel out this term, so what we are going to do is multiply the numerator by minus 1. So we are going to get minus z minus x. So this basically means that when we multiply, minus is going to shift from x minus z to minus x plus z. So I just shifted the terms. We have minus x and plus z divided by z minus x, and z plus 2, and x plus 2. So these two terms cancel out. We get minus 1 divided by z plus 2 and x plus 2. And here we stated earlier that the limit of z approaches x. So when it happens here, this becomes x. So we get minus 1 divided by x plus 2 into x plus 2, and we get, what we get is, we get our derivative, that was minus 1 divided by x plus 2 whole square. So this is the derivative we got using the alternative formula instead of using the normal formula, which was for x plus h. But using the alternative formula, we got it became more easy, and we got the we got this answer from using that formula. Alright, so this was the questions from the section for the alternative formula. Now we are going to shift towards our so after this, it's graphs. So it's given that match the functions graphed in exercise 27 to 30 with the derivatives graphed in accompanying figures. So these are the graphs. I'm going to skip that because we didn't study this at the university. And after that, we have some word problems, and we aren't going to do that as well. Then we have one-sided derivative. So it's also about the graph. So compare the right hand and left hand derivatives to show how to show that the functions in exercise 35 to 38 are not differentiable at point P. So for example, if so I'm going to solve one question out of them. So I'm going to pick the 35th one. So 35th question is, so the graph is given. It's like the graph is, so this is the graph, and this is the function. So one, we have y equals x square, and we have y equals f of x, and this line is y equals x, and this point is 0 0. Alright, so the condition for the derivative to exist is, when the slope of this function is equal to the slope of this function. Means the left derivative, the left hand derivative is equal to the right hand derivative. But in this case, if you find the slope, if you find the left hand derivative, it's not going to be equal to the right hand derivative, and it's logically correct as well. If you see the figure, if you see the graph, the slope on the left hand side is for y equals x squared, and it's more curvy than if you see on the right hand side. It's a straight line, so it's different on the left side and on the right side. These are two different slopes. So if we find the derivative, so the formula, or you can just alright, so this point is p00. So if you, alright, wait a second. Alright, so this was the 35th question, and you find the derivative of this question by using the normal definition of derivative. And when you do that, so what you're going to get is the left hand derivative is not going to be equal to the right hand derivative, and that states that as this function is continuous, but still its derivative does not exist at point P, that is at the origin. So then again we have graphs, and then we have theory and examples in exercise 45 to 48. Find the derivative, then graph y equals f of x. Alright, so I'm going to do this question. So I'm going to do the 45th one, that is y equals minus x squared. So first they want us to find the derivative of this function. So we are going to find the derivative using the alternate formula for the derivatives, that was f of z minus f of x divided by z minus x. So f of z will be minus z square minus or plus x squared divided by z minus x, and here it so this is x squared minus z squared divided by z minus x. So here if we do this, a square minus b square equals x minus z, or a minus b and a plus b. So you have x plus z divided by z minus x. So if you multiply this term by minus, you are going to get so if we multiply all of the nominators by minus, so you get minus z minus x minus z minus x. No, alright, I'm doing it the wrong way. Alright, so you have x squared minus z squared by z minus x. So alright, let's do it by the normal definition of the derivative. So you have f of x plus h, so we will get f of so it will be minus x plus h whole square minus or plus, you can say x square divided by h. So that will be minus x square plus h square plus 2xh plus x square divided by h. This is minus x square minus h square minus 2xh plus x square. So this x square cancel out. You get minus h square minus 2xh divided by h. You take h common and you have h. You take h common, you get x h minus 2x divided by h. H cancel out, or the minus x and minus, yes. So what you're left with is minus h and minus 2x. So if you apply the limit and put x h equals 0, so minus 0 minus 2x, so what you're going to be left with is minus 2x. So this is the derivative of this function, and what they want us to do next is to graph these two functions side by side. So if we graph the y equals x square, that function is going to be like this. It's because minus is not the part of x, it's separate, and x square is separate. So if it was like minus x whole square, then the function was going to be the same as it is for y equals x square. But here minus is not the part of it, so we draw the function or we draw the mirror image of the function, which is like this. And if we draw minus 2x, the graph of minus 2x is going to be like this. I've drew the graphs already, so I'm not going to waste time to and make tables and plot the points for x, and then find what the y is going to be, and then plot each individual point on the graph. I'm just going to do it directly here. So these are the graphs for the main function and for the derivative. Now what they want us to do, for what values of x, if any, if the derivative f of dash is 0. So for x equals 0, the the derivative of the function is also 0. And for what value positive, for x, because here it's minus 2x, so for values for when x it will be less than 0, the derivative is going to be positive, and for x equals greater than 0, this the derivative of f is going to be negative, just because it has a minus with the derivative. That is because when x is less than 0, the derivative is positive, and when x is greater than 0, the derivative is negative. And after that, they are telling us over what intervals of x values, if any, does the function y equals f of x increase as x increase. So they're talking about this function. So when this so from minus infinity open interval up to close interval 0, this function is increasing. So this f of x increasing, as x is increasing. And from 0 up till infinity, this function is decreasing, but x is still increasing. So these are the two things they asked us in the question. And also they said how it is related to what you found in part C. So what we found in part C was when x is increasing, when x is greater than 0, it is negative, so it's decreasing. And here when x is increasing, it's increasing as well. So this is the connection. So we have 4 more questions related to this, and then we have some word problems. I'm going to skip those. And then you have the tangent to parabola, tangent to, so this is not related. And then we have computer explorations. We are not going to do that. And then we have exercise 3.2. So I'm going to cover exercise 3.2. I'm going to make a video about it um, tomorrow. And for now, I'm going to take your leave because I'm out of time. Thank you very much.